Record. All right, so we were talking about scientific notation, and before I get back to the problems we were working on, I just want to reiterate, proper scientific notation has a coefficient times 10 to the power unit, and the coefficient is greater than or equal to 1 but less than 10, right? So the coefficient is always going to be the number 1 through 9, right? So if you have a 10, you're just going to add another power and move the decimal over. So a 1 is a 10 with a power, right? Does that make sense? So if I have something like 10 times 10 to the second, right? Proper scientific notation is actually 1 times 10 to the third, right? Because what are these numbers? 10 times 10 to the second is 10 times 10 times 10, right? 1 times 10 to the third is 1 times 10 times 10 times 10, right? They're both the same number. It's just when you write proper scientific notation, you write it like this. And then that allows you also to denote significant figures. If that decimal, if this was significant, right, you'd write 1.0 times 10 to the third. So you could keep, this would indicate significant figure. All right. So we were doing these problems. We were converting these into scientific notation. I don't know if anyone tried these. Does anyone want to take a shot? Or?
Yeah. The first one that's not done is I got 4.5 times 10 to the negative third.
4.5 times 10 to the negative third.
To the negative fourth.
Okay, so let's look at this. 4.5. Now, one thing I want to point out to you here is in the context of significant figures, this number has a 0 at the end, right? So, I mean, you're correct with the exponent. But what I'm going to do here is I'm going to add this in. Oh, that's a big 0. This is a significant figure in the sense of the measurement, right? So I'm going to write 4.50, big fat 0 for some reason, times 10 to the, and you said minus third. So yeah, you can say 1, 2, 3, minus third. So be careful. I always like to write them out and then count. I always like to count where my decimal's going. So 1, 2, 3 to the left, right? So you can consider when you're writing a number, when you're taking a number and going to scientific notation, you just convert, you put the exponent to the right, right? Right is positive, left is negative. So, right, like this is 1, 2, 3, 4 places, and this is 1, 2, 3 places. Anyone for the 752,000?
I got 7.52 times 10 to the fifth.
7.52 times 10 to the, all right. So again, let's just check our number to the fifth, right? So 1, 2, 3, 4, 5. Yes, 10 to the fifth, right? So all I'm doing here is I'm looking at this. I'm like, okay, the number's going to be 7.52 times how many tens? Let me just check. 5. I think it's going to be 5. So 1, 2, 3, 4, 5. Right? Because each time you multiply by 10, you move the decimal over 1 spot. Yeah, so now we're working the other way here. We're going to express a measurement from scientific notation. So we've got the number in scientific notation, and now we want to, express it in decimal form. So we're going to, these are basically the steps, right? Identify the coefficient, what's the power of 10, and then move the decimal point to the right or left indicated. Well, these are all to the right. So we're doing this first one's going to be positive coefficients. Add trailing zeros as space holders. So 3.95 times 10 to the third meters. Oh, we don't have units on these examples. We can see we're going to move the decimal point over 3, right? 1, 2, 3. So we would just write this out, right? Go 1, 395, 1, 2, and then another 3. Same thing with a 4.5 times 10 to the 6th meters. Here you're just going to write 6, you're going to multiply by 10 6 times. You're going to move the decimal over 6 times. So 1, 2, 3, 4, 5, 6. All right, so let's do some of these examples. So the first one, right, 5.2. So I'm going to write 52 here because I don't know anything about the decimal rate yet. Oh, okay, so now I'm going to move times 10 to the 4th. So that's multiplying by 10 4 times, right? Which means I'm going to move my decimal over 4 places. So I've got 1, 2, 3, 4. Is that right? 1, 2, 3, 4. Yeah, so I've got here 52,000. I don't have any units. So 52,000 is the answer for this one. This one here, 7.3 times 10 to the 1st. This is just going to be, I'm multiplying by 10, basically. 10 to the 1st is 10. I'm moving it over 1, so 73. You don't even really need the decimal point. All right, why don't you two try, or why don't you guys try the next two, and then I'll give you, I don't know, 30 seconds. It should be pretty quick. All right, anyone want to volunteer the number 3 there, what they got?
Under 40.
Under 40, yep. And what about number 4?
835,000.
835,000. Let's see, 835, 3. Let's just double check. Honestly, the bigger the number, the more I have to double check it, because it can get confusing counting over. And when you're adding the zeros, there's just been, I can't even count the number of times I've added I've either stopped and forgotten the 0, or I've added an extra 0 because I'm counting incorrectly. 1, 2, 3, 4, 5. Yep, 835,000. All right, let's see. We have examples here. Well, let's do that. Negative powers of 10. So this is going the other direction, right? A negative power of 10, remember, you're multiplying by 0.1, or you're dividing by 10. It's the same thing. You're going to identify the same idea. Identify the coefficient, identify the exponent, and then now you're moving the decimal point to the left with a negative. And you need to add leading zeros. So this is just an example. Oops. 3.9 times 10 to the minus 3rd, right? The coefficient's 3.95. The exponent's minus 3rd. So you're going to move that decimal point to the left 3 places. 1, 2, 3. Right? And this is typically what you do. You put another 0 in here just for clarity. So people are going to see 0.0. That's sort of the accepted way to write decimal places. Let me go to the next page. So now we're on page 15 of the handout. And oh, I gotta fix this exponent. This is all 5.0 times 10 to the negative 4th. Let me mark a little asterisk on this so I remember to go into the master file and see how many times I've revised it. I should put an equal sign here too. 5.0 times 10 to the minus 4th, right? So let's just I'll work this out since I'm, we got a 50. Now notice, right, again, going back to significant figures, the 5.0, this is telling me this 0 is significant. So I'm going to start with a 50, and I'm going to go backwards 4 places, right? 1, 2, 3, 4. Is that right? 1, 2, 3, 4 decimal point placeholder, right? So these are all placeholder zeros to show you the 0.00050. That's the measurement. All right. So let's see, down here we've got some example problems. Let's start with the first one, number 5. 745 is my, well, 7.45 is my coefficient. And I'm going to write that as 745. I'm going to move my decimal point to the left, times 10 to the negative 2. So dividing by 10. So it's 1, 2, right? I need one more 0 in here. I wonder, I feel like I'm missing something in my notes here. No, okay. The next one, 4.9 times 10 to the negative 6th. So leave lots of room on the left, right? So we're going to just count over. We're starting at 4.9. We're going to have 1, 2, 3, 4, 5. And this is where you start to get worried you're running out of space. 6. Let's count these. 1, 2, 3, 4, 5, 6. And then I'll let you guys try this on your own. So I'll give you like, I don't know, 15 seconds.
0.000394.
You say 3 zeros?
0 point and after is three zeros.
Yeah.
Yeah, that's right.
So we'll just check that, right? 1, 2, 3, 4. It checks out. Yeah, so that's how you do it. I think, again, it's fairly straightforward once you get the hang of, really the only, there's no trick to this. So the only thing about scientific notation you really have to memorize is what is this, that you have to know, right? You're multiplying by a negative exponent is 0.1, right? A positive exponent is 10. And you just look at the exponent numbers. So you're either multiplying by 10, X number of times, or you're divided by 10, a certain number of times. All right, so where's my, there it is. Another way to do this is to use what's called metric prefixes. And you'll see things, it's called engineering notation. And I think the reason is primarily because it's used a lot in engineering, right? You don't report, 7.5 times 10 to the 6th watts necessarily. You don't just talk like that, right? You're trying to communicate numbers quickly. You'll use what's called a prefix. And we've got a table of prefixes in the book. Let's see. Oh, here it is. Table 1.2 in your textbook. And maybe I should describe what they're doing first. All you're doing with a prefix is you're replacing. You're replacing the power, right, the exponent, with a prefix. So, for example, the prefix centi, right? Centi is 10 to the minus 2. It's 100th, right? Centi, 100th, 10 to the minus 2. Oh, these are a little faded. So I'm looking at that exponent, or multiplier 10 times 10 to the minus 2, and I'm going to replace it with a prefix. And you can do that for pretty much any of these, any prefix you have, or any multiplier you have, you can replace it with a prefix. So centimeters is a common one, right? This is the prefix. Let's see. Yeah, so I mean, that's basically what it's telling you, right? 9.56 times 10 to the minus second meters. That looks like this, 0.0952 meters, right? This is the same as 9.56 centimeters. And then this is an example of kilometers, 45 kilometers, right? The kilo, you go to your metric prefix table, kilo is thousands, right? That's 10 to the third. So in this case, we can replace the metric prefix by the times 10 to the third. These are just equivalent, right? You can replace the prefix, or you can replace the power with the prefix. Depends on which way you're trying to convert your number. Let's see, so that's the same as 45,000 meters, right? 45 times 10 to the third meters, 45,000 meters, or 45 kilometers, right? The kilo means thousand. So then we're going to do some engineering unit practice here. Let's see, centimeters. Centimeters we already have, but let's just write these out. So the first thing is we're going to look at these and we're going to say, all right, this is my prefix, right? Centimeters. I'm going to replace that with, oh, notice here it says just practice by replacing the metric prefix with the proper power of 10. So I'm not going to worry about putting it in proper scientific notation. All I'm going to do is replace the prefix with the proper power of 10. So I go to my table here, I see centi is times 10 to the minus 2, right? So that's 45 times 10 to the minus 2 meters, right? So notice all I did, I have a prefix, I have the unit, right? I mean, technically these are units. On a centimeter ruler, these are the units. But the SI unit is meters, right? And centi is 100th of a meter. Let's look at kilometers. My prefix here is K. And K is 1,000, 10 to the third. So I'm going to replace this with 5.9 times 10 to the third meters, right? This is the prefix. Should underscore those, right? This last one is one of the common prefixes you'll see. So I just made a little dash here next to some of the common ones. You'll hear mega a lot, right? For, well, you know, the lottery, right? Mega Millions, which seems kind of redundant. I mean, mega means a million. K is kilo for 1,000. You don't hear hectos a lot. You'll hear it in the context, the context of hectares. Hecta is not really used a lot. So 100, like, okay, hectometers, right? 100 meters. Deca, that's not a common one. Oh, I don't know why that's a, oh yeah, it's a DA. Deci is a D. The other ones you'll see a lot, centi, milli, micro, nano, right? This is when you're dealing with small stuff, especially when you start getting into, if you take any bio classes, or when we talk about, we'll talk about later on different frequencies of, you start getting into nanoscale. So centi, right, centimeter, millimeter, micro, and nano. Those are, you're going to see those a lot, probably throughout your careers. All right. Oh, I was going to do this last one. So this M is a milli. So this is 35 times 10 to the milli. It's 1,000th. It's minus third. 10 to the minus third seconds. So 35 milliseconds. That's what they measured. And then you can work the other way, right? Replace the power of 10 with the metric prefix. So let's look at some of these. In one example, right? 5.8 times 10 to the 6 watts, 5.8 megawatts. So you'll hear this. People will talk about generating power in a power plant. We'll talk about megawatts. We'll talk about gigawatts. And you see this a lot with computer data, right? How many megabytes is a file? How many kilobytes is a file? How many gigabytes of memory do you have, right? So you use those prefixes. In fact, your generation should be very familiar with all these prefixes, right? Mega, giga, kilobyte is small for you guys. When I was when I was younger, when we had like a certain number of kilobytes, that was huge. A megabyte of RAM was incredible. You know, 2 megabyte or 1 megabyte floppy, whatever. But now we've got gigabytes and terabytes. You can go out and buy a backup drive for, you know, $100 that has a couple terabytes of space on it. All right, so let's see. We're going to replace each value with its power, or each power of 10 with its value. So we got 3.6 times 10 to the minus 6 seconds. We're going to look at our prefix table. Let me move this up. Oh, it still doesn't fit. Well, times 10 to the minus 6. It's down here. We've got microsecond. This is a Greek letter mu. So this is 3.6 microseconds. Let me just make a little note here. That's mu. This is where the way it's spelled in English, I guess. And this is micro, right? So it's microseconds. 83 times 10 to the minus 1. So I'm going to put in here 83. And what are we going to replace the times 10 to the minus 1 with? We're going to look at this. Times 10 to the minus 1. That is a deci. I don't even remember the decimeter. So we're going to write dm. So this is a decimeter. And then we got 56 times 10 to the minus third. Times 10 to the minus third. There's only so many of these you can do before you start repeating milli, right? Minus third. Oh, my camera locked up. And hold on. 10 to the minus third is milli. Is this next page practice? Oh no, we got to do this in class. All right. So why don't you guys take a minute to do the first one is expressing the following measurements in scientific notation. So go ahead and do that. You all should be experts at that. And then, well, let's see. Why don't you just do the first 2 sections right now, and I'll go through them. And what I'll do is I'll put the answers in and see if there's any questions. So I'll give you, I don't know how many, like a couple minutes, 2 minutes for that. So go ahead and work on those. Yeah, so again, just do the first 2 sections and I'll go through and put the answers down. Oh. Number 7 should be 6.39, not this 480, whatever. This is a typo. Jeez. Hmm. Looks like a few of you still working. All right, let me just run through these. Again, these are scientific notation, which we've done already. It's more like in-class practice. So here we've got 5.6 times 10 to the what? We're going to move our decimal. If we have 5.6, so there's a few ways to look at it, right? You can look at it as I'm moving it 1, 2, 3, and I've got to divide to get back. Regardless, remember to put your negative sign, right? So I've got 1, 2, 3. So 5.6 times 10 to the minus third seconds. Here we've got 4.8 times 10 to the 1, 2, 3, 4, 5. 10 to the 5th meters. 7,750. We've got 7.75 times 10 to the what? 1, 2, 3.
Looks like your camera froze.
Oh, again, geez. Yeah, I don't know what's going on. My computer is I did a BIOS update the other day, and my computer is like sitting here with its fan blowing on high. I don't know what's going on. Something's taking up a lot of memory. The camera, for some reason, the camera software does actually use up a lot of memory and processor. Oh, this one, 8. So we've got 8.6. So we're using scientific notation. So again, proper scientific notation. I've got the 1 decimal place or 1 place here, and I'm going to go backwards 1, 2. So times 10 to the minus 2. Notice the units on this is centimeters squared. This is cubic meters. So here I've got 9.60 times 10 to the, I know it's going to be minus. I'm just going to figure out how many. We got 1, 2, 3, 4, 5. 9.60 times 10 to the minus 5th meters cubed. And then this is going the other way. Right, 1.9 times 10 to the 4th meters is going to be 1912. What do we got? 1, 2, 3, 4. So 19,000 meters. 6.39 times 10 to the minus third. I'm going to take my decimal points to the left. So let me just start that way. So I'm gonna have 639. I've got 1, 2, 3. So 0.00639. And then 4.8 times 10 to the 2, basically 480, right? 1, 2. And you'll start to recognize, right? You're going to start, especially the 2s, the 1s, you're going to recognize easily, oh yeah, that's 100, that's 10, right? And then the same thing with the 145. Well, same coefficient, right? Different sign. So in this case, we multiply by 2 10s. In this case, we're multiplying by, or dividing by 10 twice, multiplying by 0.1 twice. So I've got 1, 2. I'm going to have 0.0145. And then this last one is just moving the decimal over 1 to the left, right? 0.34 seconds. All right, so now we're going to go and look at the examples. Let's see. Are there 2 sets? There are 2 sets. Yeah, you know what? Do this one first and use the table. So this table's in the back of the textbook. Let me see if I can fit them all on one. I'm going to zoom out a little bit. We're going to use metric prefixes. Maybe I can put it over here. Yeah. So go ahead and replace each power of 10 with a metric prefix. So 4.6 times 10 to the minus third, 8.4. Yeah. There's your list of prefixes. And don't worry about putting in proper scientific notation. In fact, it tells you here, right? Some values are not expressed in proper scientific notation. However, they can still be represented using a metric prefix, right? So like 12, that's not proper scientific notation, but we have a prefix. We can replace this with a prefix. So go ahead and do that. Give that a minute. Whoa. Bump my paper shred. All right, so why don't I go through. 10 to the minus third. This is the milli. In fact, while I've got this table up, before I write them down, let's just call out the prefixes. Times 10 to the third, this is going to be a K, right? 1,000, so that's kilo. Times 10 to the minus 2. 10 to the minus 2. Oh, that's a centi, right?
It's a centimeter.
What? Oh, you're just,
I
yeah,
said
you're just answering. Sorry.
centimeter.
Here we've got
The next one is decimeter.
yeah, decimeter, right? And then 10 to the 6. What's that one?
And last one, mega. Mega
Right.
watt.
So let's write these out, right? We've got 4.6 millimeters, 8.4 kilometers, 12 centimeters. Here we've got 84 decimeters. And down here we've got 16 megawatts. Any questions about any of these? Well, I guess any of the above either. Anything on this page? All right, so let's go one last side here. So now we're just replacing the metric prefixes with the power of 10. Where's my table? Here it is. Right, so go ahead and take a minute to just do these. So you have, this HZ is hertz. That's the units here. These are the units, the prefix is G. Hertz is a measurement of, well, we'll talk about it later, but it's used in radio frequency a lot. Oh, it's used in frequency. Again, pretty straightforward, I think. And again, don't worry about proper scientific notation for this. We're just replacing the prefixes here. All right, so let me just go through these really quick. 65 centimeters, right? This is just 65 times 10 to the, well, 10 to the minus 2 meters. I technically should carry that decimal place over. Just rewrite this, 65.0 times 10 to the minus 2 meters. 95 kilometers, right? 95 times 10 to the third meters, right? So these are all units of, or they're all units of meters. It's just the power is denoted by a different prefix. 1.5 decimeters. So here we've got 1.5 times 10 to the minus 1 meters. This is, again, deci is a tenth of a meter, or a tenth. 2.8 gigahertz. Giga, you might have to look up, right? It's a billion, it's 10 to the 9th. So that's 2.8 times 10 to the 9th. Well, this is supposed to be a small 9, exponential 9. And the units are here, hertz, so I'm just going to leave it. And then 35 milliseconds. 35 times 10 to the what? What's milli? Milli is 10 to the minus third. So fairly straightforward, going back and forth. Any questions about any of that? All right, I do want to point out page 19. Where's my other page? Oh, page 19 here is sort of self-practice. All the answers are in the box below. So they're down there. Go ahead and do this on your own for practice. And if you have if you have questions, definitely make sure you ask me. But this is, again, just reading off of your table for the metric prefixes, and also the scientific notation, just following the rules of scientific notation. Be careful when I give you tests. I notice people seem to be able to do it when they're writing it out like this, but then when I give them a multiple choice test, they go the wrong way with their decimal. So, don't feel don't feel like you have to just look at the answer and know it. Write it out. If you have a multiple choice question and it's asking you what the correct, particularly for scientific notation, what is, write the numbers out on a piece of paper so you can look and see what they look like. And, does it make sense? Is it going the right direction, right? What's on the back here? Oh, yeah. So, I mean, that's pretty much it for mod 2.
I have a question.
Yep.
On page 18, number 20, should it be seconds? Like, should the unit be seconds?
Oh, yeah, it should be.
Okay.
It's a millisecond. Yeah, I don't know. I was so used to meters from up here. I didn't. Yeah, that's a second. You're right. That's a millisecond. Millisecond. Yep. Anything else? Any other mistakes you got? You guys are paying attention. All right, so what I want to do now is, let's see, 11:45. We don't have a lot of time, but I want to go through some of this just because it's fairly light stuff. We're going to look at unit conversions now in more detail. This is going to be, we're going to be using more exact or more precise factors. And those are also in the back of the packet. Page 31 has conversion factors that are more precise. Let's see. So for example, 1 kilometer, right, is 0.621 miles, or 1 mile is 1.609 kilometers. So these are conversion factors. I think you'll use these here. There's a similar one for the test that I'll put together, or I have put together. But what's going on here? Remember, we can treat units just like we treat numbers. We can multiply, we can divide, we can, we're just going to have units left, right? We're not going to have like a unit times a unit isn't going to give you an answer. It's going to give you like unit squared or unit cubed, right? Let's see. So these are conversion factors. And the first one here is convert 19 cubic inches to cubic centimeters, right? So the first thing we recognize is that our conversion factor is, well, it's given 1 cubic inch is 16.39 cubic centimeters. I'm going to write that here. 1 inch cubed is 16.39 cubic centimeters, right? This is saying that this is equal to that, and this is equal to that. So the way you can do this is you can set it up using a ratio or a multiplication formula where you have your original measurement, and then you have your equivalent conversion factor with the target units you want, right? And then the original units on the bottom. And then you'll get an answer with the target unit. So let's look at how this works. And this helps you convert between units. If you only know one of the conversion factors, this is the way you want to try to do it. And you're really doing this in your head when you did some of the problems earlier. But now, again, we're dealing with more numbers, more accuracy. Oops, what am I I'm writing the wrong problem down. This is 19 cubic inches. All right, 19 cubic inches. This is our original measurement, right? We want cubic centimeters. So that's the unit that's going to be on the top here. And what do we have? We have 16.39 cubic centimeters. Is the same as 1 cubic inch, right? This ratio here, this is equal, or this is basically 1, right? We're saying 16.39 cubic centimeters is the same as, identical to 1 cubic inch. And what happens? Well, the units cancel out. So we're left with, let's see, the cubic inches and cubic inches cancel out, and we're left with 311.41. And the units on this are cubic centimeters. And there's another page here where they basically, there's more stuff to read if you want. 311.41 cubic centimeters. Oh, well, the units are out here. Oh yeah, it was talking about units. Now we look at this number, we say, okay, how many significant figures do we, oh, we're rounding here. There's too many steps. I gotta eliminate some of these steps. All right, now we're rounding to significant figures. We were given 19 cubic inches. We've got 2 significant figures in our lowest number of significant figures. So we're going to round this to 310 centimeters cubed. All right, so, you know, before Wednesday, just go through the next 2 problems, 2 and 3, and I'll walk through them again on Wednesday, but it'll sort of give you an idea. Try it out yourself, see what you're getting, and do the answers.
311? Sorry.
Oh, well, yeah, it was 311 up here, but we're rounding to 2 significant figures.
Oh, okay.
Yeah, so now this is where we're using significant figures in our measurement.
Okay.
310, yep. So yeah, go ahead and take a look at the next 2 problem statements, 2 and 3, and then we'll do some more conversion problems. Oh, actually, you know what? Some of these are on your own, but then let's see. If you want to try them on your own, you can. The last or additional conversion problems. These actually come first, and then we've got more. I must have put these in the wrong order on the page. Oh, these are approximations. We're going to skip some of that. So this is just basically doing more detailed conversions now. It's a fairly quick, the unit conversion is fairly quick. Then we're going to get into proportionality and density. So yeah, have a good Monday. Have